In this video, we are going to evaluate the series 1 times 2 times 3 plus 2 times 3 times 4 plus 3 times 4 times 5, all the way adding up to 97 times 98 times 99. Before we move on, don't forget to give a like, subscribe to my channel, and turn on post notifications. To evaluate this series, I'm going to rewrite each term into the following. For example, for 1 times 2 times 3 is in general of the form n minus 1 times n plus 1. This is because they are 3 consecutive natural numbers. With this general form, then 1 times 2 times 3 is taking the case when n is equal to 2, while 2 times 3 times 4 is taking the case when n equals 3, and so on, up to when n equals 98. Now, for this general form, we can expand and get n squared minus 1 times n, and that's n cubed minus n. So that means to evaluate this series, I'm going to write the sum of n cubed minus n from n equals 2 to 98, and I can separate that into considering n cubed and n separately. Now for the sum of cubes, the formula is actually recalling that maybe I should not use n here, maybe I should use k. If I'm going to add the first n cubes, then the sum is actually this expression, n squared times n plus 1 all squared over 4. Or a better way to memorize the pattern would be just saying that is the sum of the first n numbers whole squared after the sum. Not just sum of squares, but the square of the sum. So from this, you can do the original series, and that's if I'm adding from 2 cubed to 98 cubed, then I can just consider that as adding the first 98 cubes and then minus 1, minus the first term. So minus 1, that's our first expression. And then for this, we can do the same thing. Just keep the original summation. Then for the things inside the bracket, it is 98 times 98 plus 1 all divided by 2 whole squared minus 1. While for the ending summation, adding from 2 to 98, is actually an arithmetic sequence. So I can do that with the formula, the first term plus the last term, multiplying by the number of terms, and that's 98 minus 2 plus 1, and then all divided by 2. So then you have 49 times 99 whole square minus 1 minus 100 times 97 over 2. And by computing, we know this is equal to 2352735 This is the answer to the series. There is actually another thing about this problem, is that from the original statement in the IMO long list, the first part of this problem is actually to prove this identity, although it's actually bookwork. And then we have to use this identity to evaluate the previous sum. So to quickly go through the reason why this identity holds for all natural numbers n and p, where n has to be larger than p, or n is larger than or equal to p, and p is at least 1. The reason is that we can make use of this identity, known as the hockey stick identity, which is that n choose p can be written as n minus 1 choose p plus n minus 1 choose p minus 1. Firstly, this can be explained by how we choose objects, from n objects. So we have a1, a2, all the way up to an, and we have to choose p items among them. So the number of ways to choose them is equivalent to splitting into two cases. The first case is choosing a1, and then after that, then we can choose p minus 1 items among the remaining n minus 1 items, or we choose to not pick a1, then in that case I'll have to choose p items among the remaining n minus 1 items. So this tells us that this identity holds for all n and p. Now from this is kind of an induction, and from this we can rewrite this term as n minus 2 choose p plus n minus 2 choose p minus 1, using a similar argument. Then this term can go down again, doing the same thing, at the same time lowering this number by 1. So as we keep iterating this process, we'll have this hockey stick identity. Now, the second way to evaluate the previous sum, by using this result, is to take a look at what happens when p equals 4. When p equals 4, I can say that n choose 4 equals n minus 1 choose 3, n minus 2 choose 3, all the way down to 3 choose 3. Now, for an arbitrary number choose 3, say, let me use another alphabet. m choose 3 is actually equal to m factorial over m minus 3 factorial times 3 factorial, and that's m minus 2 times m minus 1 times m over 6, and this part actually contributes to our series. So that means m minus 2 times m minus 1 times m equals 6 times m choose 3. Now using this, I can say that our required series 1 times 2 times 3 is actually equal to 6 times 3 choose 3, and then 2 times 3 times 4 equals 6 times 4 choose 3, and all the way down to 97 times 98 times 99, that equals to 6 times 99 choose 3. And we know that if we add them up, is equal to adding these binomial coefficients, and for this I can first take out the 6, and that equals to 3 choose 3, 4 choose 3, all the way up to 99 choose 3, and the things inside the bracket is equal to, according to the hockey stick identity, is equal to when n equals 100 and p equals 4. So that's 6 times 100 choose 4. Now to evaluate this, we have 6 times 100 factorial over 4 factorial times 96 factorial. And that's 97 times 98 times 99 times 100 times 6 over 4 factorial, and that's actually times 6 over 24. So this product divided by 4. And this also equal to 23527,350. And so this is the second approach to evaluate the required series. Please feel free to share your ideas in the comments. Thank you for watching. See you next time.